The classification of matter. Matter is anything that occupies space and has mass. For example, your desk, your chair, and even your body. We're all composed of matter. We classify a specific instant of matter, such as air, water, and sand, as substance. We classify matter according to its state, its physical state, and its composition, the basic components that make up that matter. And the states of matter are solid, liquid, and a gas. In a solid matter, atoms or molecules are packed closely to each other in fixed locations. Although atoms and molecules in a solid evaporate, they do not move around or pass each other. A solid matter has fixed volume and wedge shape like ice, aluminum, and diamonds. Solid matter can be crystalline, meaning the atoms and molecules are in patterns with long range repeating order. Or they can be amorphous, they do not have long range order. In a liquid matter, atoms and molecules are packed as closely as they do in a solid matter, but not in a fixed shape, and they are free to move relatively to each other, giving a liquid a fixed volume but not a fixed shape. Liquids tend to assume the shape of their container, for example, a bottle of water, alcohol, and a gasoline. In a gas matter, atoms or molecules have a lot of space between them and are free to move relatively to one another, making gaseous compressible. When you squeeze a balloon or you sit down on an air matter, you are forcing these atoms or molecules into smaller space so that they are close together. And gases, they always assume the shape of their container as well. Substances that are gas at the room temperature, like helium, nitrogen, which makes up the main component of air, and carbon dioxide. And we can see in this picture the main difference between a solid matter and a gas matter. A solid matter can't be compressible because it is solid, it's firm. While a gas matter, because we have too much space between these atoms, a gas can be compressible. The other section of this lesson is about substances. What is pure substance? Pure substance is made up of only one component and its composition is invariant, meaning it does not vary from one sample to another. The components of a pure substances can be individual atoms or groups of atoms joined together. For example, helium, water, and table salt, sodium chloride are all pure substances, each of them made up of only one component. Helium is made up of helium atoms only. Water is made of water molecule, and sodium chloride is made up of sodium chloride units. The composition of pure sample of any of these substances is always exact the same, because you can't vary the composition of a substance made up of only one component. A mixture is composed of two or more components in proportions that can vary from one sample to another. For example, sweetened tea is composed of water and sugar molecules, and with a few other substances mixed in. That is a mixture. We can make tea slightly sweet if we add more sugar to our water, or we can make it very sweet if we add a large proportion of sugar to this water. So as you can see, we can play around with the ratios. That is the main difference between a pure substance and a mixture. A pure substance is always exactly the same, but a mixture, we can add more and introduce new substances to this mixture. We have two types of pure substances. We have an element and a compound. An element is just like any element in the periodic table that cannot be broken down into simpler form. For example, oxygen, helium, nitrogen, iron. They cannot be broken down into simpler form because they are already in the simplest form. A compound, on the other hand, is a substance that is composed of two or more elements, like hydrogen and oxygen of a water molecule. They are fixed, defined portion, and on Earth, compounds are more common because elements tend to combine with other elements to form a compound. And we also have two types of mixtures. We have heterogeneous and homogeneous mixture. A heterogeneous mixture, that is, the composition varies from one region of the mixture to another, like wet sand. A heterogeneous mixture are made up of distinct regions because the atom or molecules, they tend to separate. Just a reminder, we said before that properties of matter determined by the atoms and molecules that compose to it. Homogeneous mixture is totally different. Homogeneous mixture have a uniform composition because atom and molecules that compose them mix uniformly. If we look at the bottom, we have two pictures. The first one is about mixtures. We have that you can see clearly the difference between a heterogeneous mixture and a homogeneous mixture. A heterogeneous mixture, as you can see, the atoms are separated from the other atoms, while in a homogeneous mixture, they're all mixed together. The third picture is about pure substances. We can see the difference between an element and a compound. The element is one simple element, and as we can see in the first circle, we do not have foreign color, meaning that we have the simplest form of that element, while in the compound circle, we have two colors. We have a green and purple, that meaning that compound is composed of two or more elements. Physical chemical changes and physical chemical properties. Every day we come across changes in matter. For example, ice melts, iron rusts, gasoline burns, fruit ripens, and water evaporates. But what happened to these molecules and atoms that compose to these substances during this change? The answer depends. If this change alters the composition of these substances, it means this is a chemical change. But if it does not, then it means it's a physical change. A physical change, a change that does alter only the state or the appearance of these substances. Atoms or molecules that compose to a substance do not change their identity during a physical change. For example, when water boils, it changes state, it becomes gas, but we still have the water molecule in it, so that means it's a physical change. Changes that does alter the composition of the matter are chemical change. A physical change results in a different form of the same substance, but a chemical change result in a completely different substances. During a chemical change, atoms rearrange, transforming the original substance into a different substance. For example, the rusting of iron is a chemical change. The atom that composed iron atoms combine with oxygen molecules to form iron oxide, which is the orange color that we see on the rusting iron. And as we can see here, we have the physical and chemical changes are a result of chemical and physical properties. A physical property is a property that a substance displayed without changing its composition. For example, the smell of gasoline is a physical property because gasoline does not change its composition when it exhibits its odor. A chemical change, on the other hand, a chemical property, on the other hand, is a property that the substance displays only changing its composition by a chemical change. For example, the flammability of the gasoline in construct is a chemical property. A gasoline changes its composition when it burns, turning into new substances, mainly carbon dioxide and water. And if you look at the bottom, we have the clear classifications of physical properties and chemical properties. For example, physical properties, we have odor, taste, color, appearance, melting point, boiling point. Chemical properties, we have corrosiveness, flammability, acidity, and toxicity. Okay, let's do this question. It says determine which one is chemical and which one is physical change. Now we have the first one is the evaporation of rubbing alcohol, and you guessed it, it is a physical change. Just like water, when we evaporate water, first we're gonna have liquid water and then we're gonna have a gas, but we're gonna still have our water molecule, so this is a physical change. The second one, we have the burning of lamp oil. When we said flammability, it is a chemical property, so that means this is a chemical change. The bleaching of hair with hydrogen peroxide. If you bleach your hair, I'm so sorry for you, but this is a chemical change because we're not only changing the hair, we're changing the composition of the hair. So this is a chemical change. And the last one, the formation of frost on a cold night. This is basically a physical change. I don't have to explain myself. Okay, let's see this question. So the diagram on the left represents liquid water molecules in a pen. Which of the three diagrams, A, B, or C, best represents the water molecules after they have been vaporized by boiling? So as we can see, A has two water molecules. We can see one oxygen bounded to two hydrogen atoms, and the same for the other one. B, this one is unique. We have two hydrogen atom, which is hydrogen gas, and two oxygen atom, which are oxygen gas. Number C, the atoms are completely broken down, so we no longer have water. That means C is incorrect. B is incorrect because here we have separated oxygen and separated hydrogen atoms, they're gas. And so the best answer would be A.